Hello everyone, we are Group 21 and this video is about rock mechanics, G-force soil classification experiment. So let's start with the introduction. Schmidt hammer test or rebound hammer test is a non-destructive testing method of concrete which provides a convenient and rapid indication of a compressive strength of concrete, and due to its advantages, it becomes very popular among the construction field. And SH rebound's hardness value R is the most frequently used index in rock mechanics practice. So this helps to estimate the unconfined compressive strength, UCS, and the modulus of elasticity, E, of an intact rock in laboratory conditions. So the Schmidt hammer is also used to estimate the UCS of discontinuity walls and assessing the workability, excavatability, and bore quality of rocks by any mechanical means. And this device is so portable that can be used both in laboratory and field. Thank you. That's all from me, and I'll pass to my next team member.
Hi, Assalamualaikum. My name is Muhammad Aznizan Amri, and I will show you how to conduct the Schmidt rebound hammer test. In this experiment, the apparatus needed is the Schmidt rebound hammer L type. So we don't have the Schmidt rebound hammer alongside, so let's just pretend this mechanism as a Schmidt rebound hammer. So to conduct the experiment, we need to put the impact of the Schmidt rebound hammer to the specimen, and the reading will appear on the Schmidt rebound hammer. For an example, for the first impact, we get 40. The first data is 40. In this experiment, we need to take 20 readings. So the average of the reading will be calculated from the 20 reading that we take by the Schmidt rebound hammer. From the average readings of the Schmidt rebound hammer, we can calculate the uniaxial compressive strength of the rock specimen.
Okay, for the Schmidt rebound harness test, the result is we already been given the rebounds number data, and then we need to complete the UCS. Okay, for the UCS, we refer to the graph, and then we can acquire the data for the UCS, and we say inside the table, and then we also calculate for the average for rebounds number value, which is the rebound number divided by the number of data, and then from there we get 41.1. And for next step is we need to calculate for the average for UCS value, which is in the megapascal unit. For this average for UCS value, we obtain from UCS data divided by number of data, and then from there we get 94 megapascal. Since our rebound number is equivalent to the UCS, so the compressive strength for this sample, which is 94 megapascal or 94 Newton per millimeter square. And from this test, the UCS value obtained which is 94 megapascal, which is considered as a very high for the strength classification of intact rock. Okay, for the guided result, from the sample 1, for the lithologic descriptions of rock is a very high. For the type of specimen is a granite type. And for the shape and size of the specimen is a cylindrical in shape, and for the size is 42 times 54 millimeter. The orientation of hammer is in the vertically downward, and there's no clamping for the method of specimen clamping. That's all. Thank you. This is the graph that we have been using to calculate the UCS, and from here we also get the UCS average, which is 94 megapascal.
Okay, so now we move on to the discussion. From the results, we found that the compressive strength of granite is 94 megapascal in standard chart figure 20. These results obtained based on the average rebound value of 20 test locations. According to ISRM 1979, the granite is considered as strong strength rock as the range of compressive strength is in between 50 to 100. We believe that there are errors in an experiment. After discussing it with group members, we listed some factors that may possibly affect the accuracy of the readings. The first one is the Schmidt hammer is not handled properly. This may possibly happen when the person is only holding the Schmidt hammer by one hand, which may tilt the Schmidt hammer and will cause the results inaccurate. The second one is the cleanliness of the specimen surface. As the Schmidt hammer test will be conducted on the surface of the specimen, dirty device may cause difference in rebound value. The third one and the last one is the Schmidt hammer is not locked on time after the bounce sound is heard. This will cause the rebound value to be vary and misread the values.
From the results, we have obtained the hardness and unaxial compressive strength of the granite. Therefore, we have achieved the objective of this experiment. In general, the rebound number increases as the strength increases, but it is also affected by several parameters such as size, age, surface smoothness, moisture content, etc. Rebound hammer method can be a suitable and a convenient way for field identification of the sample and estimating their compressive strength, but this method does not give you true value of strength, and hence its application should be limited for inspection purpose only.